All right, class, what we're going to do is talk about how we get our chemical formulas for all of our compounds. Remember what we went over in the beginning of the year? A formula shows you the kinds and numbers of atoms that represent that smallest unit of a molecule or a formula unit compound. But basically, for our covalent compounds, everybody wants to be a noble gas. So they all obey something called the octet rule. Everybody wants 8 valence electrons, like the noble gases. Okay, if you remember back to our electron configurations, the noble gases had a full S and a full P electron configuration, which means S2P6, meaning 8 outer electrons. The only exception to this, which I'm sure you're used to by now, is hydrogen. Hydrogen only wants 2 because his closest noble gas is going to be helium. All right, so valence electrons are those outermost electrons in your electron configuration. Okay, so these valence electrons here are really just that outer S and that outer P adding up to 8. So we're going to draw something called Lewis dot structures, which you probably have done a little bit in bio class. They're sometimes called just dot structures or Lewis structures, but it uses the name or symbol of that element and its group to determine the number of valence electrons. So if we quickly take a look at our periodic table, we're only going to do this with the representative elements again, because it's going to have the biggest pattern that's discernible. So that means we have groups 1 and 2, and then 13, 14, 15, 16, 17, over to 18. Okay, we're going to do period 2, which is row 2. And what I usually do for my pre-class here is have you guys write the electron configurations. All right, so for lithium is 1s2, 2s1. For beryllium is 1s2, 2s2. For boron, 1s2, 2s2, 2p1. 1s2, 2s2, 2p2. 1s2, 2s2, 2p3. 1s2, 2s2, 2p4. 1s2, 2s2, 2p5, and 1s2, 2s2, 2p6. So what we have seen from our previous chapters, no problem, we got that all taken care of. So what we're looking at for our valence electrons is the outermost level. So that means the 2s and beyond. So how many valence electrons are here? There's just 1. How many valence electrons are for beryllium? There are 2. How many are available for boron? There's 2 plus 1, or 3. How many for carbon? 2s2, 2p2. So that's 2 and 2 is 4. 2s2, 2p3 is 5. 2s2, 2p4 is 6. Do you see the pattern? 7 and 8. You'll also notice that if there's 3 in column 13, 4 in column 14, 5 and 15, 16, 17, and everybody wants to be a noble gas. So the Lewis dot structure has you use their symbol, lithium, and then you put a dot somewhere on one of the 4 sides. Now, it's going to change totally dependent on how you're going to draw your formulas. Okay, so beryllium is going to be 2 dots. Boron is going to be 3 dots. It doesn't matter where you draw them. Carbon, there's only one way to draw it, is going to be 4 dots, like so. Nitrogen has 5 dots, 4 sides. 1, 2, 3, 4, 5. So this side up here is actually going to make something called a lone pair. All right, this lone pair is a non-bonding pair. So nothing can bond there. You can also draw a lone pair as a set of connected lines. Basically, it's connected dots. Okay, so what about our oxygen? All right, oxygen is going to have 6 dots, 4 sides. 1, 2, 3, 4, 5, 6. So we can also draw it this way. We can also draw oxygen, 1, 2, 2 lone pairs, 2 dots. That's why water looks like this, right? Because it only has 2 available electrons for bonding. Nitrogen is going to have 7 dots, 4 sides, so it's going to look like that. I'm sorry, fluorine, oh my goodness. No wonder it looked so wrong to me. Fluorine is going to have 7 dots, 4 sides, so you can also see it written like this. Just be careful you don't think it's Florida. And neon is 1, 2, 3, 4, 5, 6, 7, 8, or almost completely in boxed. Don't actually draw a box around it. Draw 4 lines to show the 4 lone pairs. So there is no bonding going on over here. All right, if you take a look at this next picture, you'll see that this is again going to have our representative elements, columns 13, 14, 15, 16, 17, and 18. But everybody in column 1 has 1 dot. Everybody in column 2 has 2 dots. Bromine and aluminum have 13 in column 13, so they have 3 dots. 4, 5, 6, 7, 8. And I want you to point out something very special and important here. Check out helium. Helium is not the same thing as beryllium. Beryllium has 2 available for bonding, 2 electrons available for bonding, whereas this is a lone pair, so these are non-bonding. You do not see any bonding going on. So usually people write it like this, hee hee hee. That's HE repeating. Yeah, I guess you can write it that way, but it kind of looks like hell. So definitely do not do this with a dot here and a dot there. It's not going to work out and won't be correct. All right, but the rest of them all have their available dots. And just to point out for you, these lone pairs that you see are the non-bonding pairs of electrons. So they can be written like so as well. They can be represented as 2 dots or 1 line. All right, so the next video is going to be putting all these electron dots together to make our lovely little electron dot structures of our compounds. We're going to connect the dots. Check out the next video.